Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to study about the topic emission and the absorption spectra. Before studying this topic, let us understand what is actually spectra. So let us first of all understand what is spectra. So, when any electromagnetic radiation passes through a photographic plate, it leaves some impression on that, and that impressions are according to the wavelength of that electromagnetic waves, and that's called spectra. So, I'm writing when any electromagnetic waves or radiations or radiations passes through the photographic plate, it leaves some impression on that. It leaves some impressions on that plate, comma, that impressions are according to the wavelength, of EM waves, the electromagnetic waves, and termed as spectra. So that impressions of EM waves according to their wavelength on photographic plate are termed as spectra. So that was the spectra. Now let's discuss about the emission spectra. First of all, so I'm writing emission spectra. Emission spectra. So now, as we know that with the increasing distance of orbit of stationary states from the nucleus, the energy of electron in that stationary state increases. So when an electron transits from the high stationary state to the lower stationary state, obviously it will emit some energy in the form of photon. So we made that photon to strike on the photographic plate to give some impressions, and that impressions will be termed as the emission spectra. So I'm writing this for you. First of all, I'm writing with the increasing distance of orbit, or more specifically shell, or you can say the stationary state. So with the increasing distance of stationary state from the nucleus, the energy of electron in that stationary state also increases. And that stationary state also increases. So now what will happen? when electron makes a transition, when electron makes a transition from higher stationary state, from higher stationary state to the lower stationary state. When an electron makes a transition from a higher stationary state to a lower stationary state, it will emit the energy difference of both stationary states in the form of photon. In the form of photon. That photon of light that photon of light emitted by electron during transition is made to strike on photographic plate. Is made to strike on photographic plate. So now impressions obtained on photographic plate will be termed as emission spectra. So the impressions obtained on photographic plates will be termed as emission spectra, as that spectra has been obtained by the photon that has been emitted by electron during a transition from higher energy state or stationary state to the lower stationary state. So the photon that has been emitted will have the energy equal to the difference between the both the stationary state, and that photon is made to strike on the photographic plate. So whenever a photon strikes a photographic plate, it will give you some impression and that impression are termed as emission spectra. Now let me explain this thing diagrammatically, but one thing more. Emission spectra, so the emission spectra, it is the impression of a photon when it strikes the photographic plate. So it will be the bright lines. So it will be the bright lines against dark background. Against dark background. So let's come on the diagram. Let us, we are having plus ZD, that's my nucleus. Assume this is to be the first stationary state, the second stationary state. Now let us assume the electron is present in the second stationary state. So this is my, first of all, second stationary state, that's my first stationary state. The electron is present in the second stationary state. Now when the firstly the second stationary state will have a high energy. Let's represent the energy of second stationary state by E2 and the energy of first stationary state by E1, and we know that the energy of second stationary state is greater than the energy of first stationary state. So whenever an electron makes a transition from higher stationary state to the lower stationary state, so this is the transition made by electron from second stationary state to the first stationary state, sorry. So the energy difference of second and the first stationary state, that is E2 minus E1, will be emitted in the form of photon, will be emitted in the form of photon by electron. We got a photon that has been emitted by electron during a transition from second stationary state to first stationary state. Now the energy of this photon will be equal to the hc by lambda, which is equal to the energy difference between the second stationary state and the first stationary state. Now this photon is made to strike on the photographic plate. Let me have a photographic plate over here. This is the photographic plate. Assume this to be the photographic plate. Now when this photon will strike this photographic plate, you will have some impressions over here, and that impressions will be the bright lines against dark background, and which are termed as emission spectra. So that's all. This was my emission spectra. So now let's talk about absorption spectra. Now I'm discussing absorption spectra. So now the absorption spectra will be the vice versa of the emission spectra. What will happen over here? The electron will make a transition from lower stationary state to the higher stationary state by absorbing a certain EM radiations or photons of particular wavelength having energy equal to or more than the energy difference between the two stationary states. So let me write this thing. So what is absorption spectra? So first of all, I'm writing when an electron makes a transition, when an electron makes a transition from, now it's a reverse, from lower stationary state, that is the orbit having lower energy, from the lower stationary state to higher stationary state, obviously it will absorb some energy. By absorbing a photon of light from incident radiation, Now the energy of a photon that has been absorbed, the energy of photon absorbed by the electron will be equal to will be equal to or greater than energy difference of two stationary states. So if the energy of photon is equal to the energy difference between the two stationary states, the electron will jump from lower stationary state to higher stationary state. If energy is greater than the difference between the two stationary states, the electron will obviously jump, but the extra energy will be converted into the kinetic energy of that electron. So, uh, so I'm writing. So how will you get the absorption spectra then? So I'm writing when a white light, I'm writing when a white light having all the wavelengths is passed through the electron in lower stationary state or orbit, the electron will absorb a photon of certain wavelength and transmit the rest photons. Then the transmitted rest photons are made to strike on the photographic plate. So obviously the impressions will be there on the photographic plate, but some impressions will be missing of the photons that have been absorbed by the electron. So that missing impressions will be the dark lines against the bright background, and that's the spectra and termed as absorption spectra. So I'm writing when a white light when a white light having all photons of different wavelengths are passed through the electron are passed through the electron in lower stationary state. The electron present in lower stationary state. So what will happen? The electron will absorb a photon. The electron will absorb a photon required for its transition required for its transition and will transmit rest photons. Now the transmitted photons which are not absorbed by electrons, the transmitted photons by electron are made to strike on photographic plate the impressions will be obtained. The impressions will be obtained obviously. The impressions will be obtained in which certain lines are missing, in which certain lines are missing. Which lines are missing? The lines that have to be made by photons which have been absorbed by electron. So the photons that have been absorbed by electron are missing in the transmitted radiation, so the lines will be missing that were used to made by that photons which have been absorbed. So certain lines are missing. As some photons, certain lines are missing. Certain lines are missing as some photons have been absorbed by electron. Have been absorbed by electron. So if certain lines are missing, so that will be, the impression will be like, this will be the vice versa. Dark lines, the missing lines, or you can say the dark lines. The dark lines are obtained because the photons have been absorbed by the electron in the incident radiation. So the dark lines against bright background. The dark lines against bright background. So these dark lines against bright background are termed as absorption spectra. Now let me explain this thing diagrammatically. Now assume this is the nucleus plus Zd. This is the first stationary state. This is the second stationary state. So I'm writing, this is the first stationary state, and this is the second stationary state. The energy of first stationary state is E1, the energy of second stationary state is E2. Now let's assume electron is present in the first stationary state and has to jump to the second stationary state. So obviously it has to absorb a certain photon of light. So what will we do? First of all, the photographic plate is present over here. I'm writing, this is the photographic plate. Now what will happen? Now a white light is incident on the electron. So this is the white light incident on the electron, and after transmitting through the electron, that white light is made to strike on the photographic plate. So what will happen? What will happen that, hold on, what will happen that electron will absorb certain photons of light. The electron will absorb certain photons of light. So that photons are blocked. That photons are blocked to strike the photographic plate. Let me change the color because it's not. Now certain photons are blocked by electrons. Certain photons are absorbed by electrons, sorry. So they are not available to strike on the photographic plate. So what I'm trying to say over here, that electron will absorb certain photons of light, so that photons are not available to strike on the photographic plate, due to which the impressions made on the photographic plate will have certain dark lines, and that dark lines are termed as and that dark lines are termed as absorption spectra. Hopefully, my dear students, you got this point. I'm repeating it again. When the white light is incident on the electron in the first stationary state, when the white light is incident on the first stationary state, the electron will absorb certain photon of light from the white light and will jump to the second stationary state. Now, when the white light has transmitted through the electron, the photon that have been absorbed by electron is missing in the transmitted light, so there will be dark lines in the spectra obtained on the photographic plate, and that dark lines are called the absorption spectra. So this was the absorption spectra. So now let's talk about one more topic in this case. Now, the important point is over here is that the energy of a photon absorbed by electron must be equal to or greater than the energy difference between the second and the first stationary state, but it must not be equal to the energy difference between the third and the first stationary state, otherwise the electron will jump in the third stationary state. So I'm writing this thing. So here I have taken the example of second and the first stationary state. So I'm writing the energy of a photon. The energy of a photon absorbed by electron must be equal to or greater than energy difference between the second stationary state and the first stationary state. So if the energy of a photon will be less than the second energy of a photon will be less than the difference between the second stationary state and the first stationary state, the electron will not jump. If it will be equal to, the electron will jump, and if it is minutely greater than, then the extra energy will be converted to the kinetic energy. So I have written the energy of a photon absorbed by electron must be equal to or greater than the energy of second station, greater than the energy difference of second stationary state and the first stationary state, but not be equal to energy difference between the third and the first stationary state, otherwise electron will jump in third stationary state. So that is I'm trying to say the energy of photon that has been absorbed by the electron, energy of photon absorbed by electron must have energy greater than or equal to the energy difference between the second stationary state and the first stationary state, but not equal to the energy gap between the third and the first stationary state, otherwise the electron will jump in the third stationary state. So that was the topic. So that was the absorption spectra. So in the absorption spectra, what has happened? The white light, when a white light having all the photons of different wavelengths is passed through the electron in the lower stationary state, the electron will absorb a photon of certain wavelength to jump to the second stationary state, and a transmitted light is passed through the photographic plate. When the transmitted light is passed through the photographic plate, certain impressions have been obtained, but in that impressions the dark lines have been obtained, and that dark lines were actually that of the photons that have been absorbed by electron to jump to the second stationary state. So that dark lines are termed as absorption spectra. So that dark lines are termed as absorption spectra. So absorption spectra will be dark lines. against bright background. Bright background. So that was the absorption spectra, and that was the emission spectra, and initially I have explained you about the water spectra. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid online one-to-one class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.